Prepare to be stunned. The world's most audacious innovator, Elon Musk, has just unveiled his most ambitious project yet. Forget electric cars. This is the game changer, a machine born from cutting-edge technology and a touch of the unexpected. Witness the unveiling of the Tesla tank, a creation that will leave you questioning everything you thought you knew about warfare. Brace yourselves for a revelation that will shake the very foundations of global defense. Hybrid electric tanks represent a significant leap forward in military vehicle technology, promising enhanced efficiency and agility compared to traditional fuel-hungry tanks. The integration of hybrid engines, combining diesel engines with electric motors and batteries, addresses some of the critical limitations of traditional tanks, such as fuel consumption and mobility. A prime example is the Abrams X technology vehicle, which allegedly demonstrates a 50% reduction in fuel consumption compared to the conventional M1 Abrams, a tank known for its massive fuel requirements. This shift to hybrid power allows tanks to operate over longer distances and for extended periods without the need for constant resupply, providing military forces with a significant advantage in sustained operations. Beyond fuel efficiency, hybrid electric tanks also offer increased reliability. Traditional gas turbine engines, like the one found in the M1 Abrams, are complex and prone to mechanical issues, especially in harsh battlefield conditions. In contrast, hybrid electric engines are generally more reliable and require less maintenance, which is crucial in combat zones where access to repair facilities can be limited. The reduced mechanical complexity of hybrid engines makes these tanks less likely to experience downtime, ensuring they remain operational in critical situations and reducing the overall logistical burden on military forces. The hybrid electric tank also brings about quieter operation. Traditional tanks, making use of gas turbine engines, are extremely loud and therefore obvious to enemy forces who depend upon noise levels for their position location. Hybrid electric engines make much less noise, making stealthy operations through the tanks easier. Quieter tanks are harder to detect, which is especially valuable in situations where surprise or close proximity to enemy lines is critical. This advantage also makes hybrid tanks less vulnerable to detection by drones and other surveillance technologies, which are becoming increasingly prevalent in modern warfare. This reflects the broader interest in sustainability within military operations. Reducing fuel consumption will not only increase the operational capability of tanks, but also make for a more environmentally friendly way of war. In an era where resource conservation is becoming more important, hybrid engines contribute to decreasing reliance on fossil fuels, which will be limited during long conflicts and prove expensive when such resources are scarce. Hybrid electric tanks could be the future of more sustainable armored combat, being more energy efficient and emitting less, making them a crucial part of the next generation of military vehicles. But what if the technology behind these hybrid tanks could revolutionize not just the battlefield but the entire way we think about military innovation? The evolution of military technology has been a driving force in shaping the outcomes of conflicts throughout history. From the advent of firearms to the development of mechanized vehicles, each leap forward has fundamentally altered the nature of warfare. One of the most significant breakthroughs in modern military technology was the introduction of tanks during World War I, revolutionizing land combat. Tanks provided a combination of mobility, firepower, and protection, allowing armies to break through entrenched positions and change the dynamics of the battlefield. As warfare continued to evolve, tanks became more powerful and sophisticated, solidifying their role as essential tools in military operations. Fast forward to the 21st century, and military technology is on the brink of another monumental shift, thanks to advancements in electric vehicles and artificial intelligence. Elon Musk, a leader in transportation innovation, has been a driving force in reshaping the future of vehicles, not only in the civilian sector but also within the context of military applications. Imagine a world where tanks, traditionally large, fuel-hungry machines, are replaced by electric-powered armored vehicles designed to be more efficient, agile, and responsive. The growing influence of electric vehicle technology promises to bring a seismic shift to military operations, with potential improvements in mobility, logistics, and even battlefield strategies. These technological advancements range far beyond the battlefield itself to impact war at its very fabric. Traditional tanks, for example, such as the M1 Abrams or the Soviet-era T-72, are indeed powerful machines but pose many challenges, especially regarding their weight, fuel consumption, and dependence on complicated supply lines. In modern wars like the current Russo-Ukrainian war, these weaknesses have been glaringly obvious. Hybrid electric technology would make future military tanks more fuel-efficient, quieter, and more easily transportable. Many long-standing logistical headaches that have thus far plagued military planners may finally be alleviated. These innovations would enhance the strategic capabilities of military forces while diminishing their dependence upon fossil fuels, making them flexible in the challenges of modern warfare. Further into the future, land warfare will be further transformed with advanced military technologies, and a key role will be played by artificial intelligence, automation, and lightweight materials. Routine tasks are taken over by AI-driven systems, which free up the time of the tank crew for mission-critical decisions rather than bogging them down with manual operations. Meanwhile, breakthrough technologies such as hybrid engines and high-tech armor are already poised to make the tanks of the next century a blend of firepower, protection, and mobility. This generation will change tanks at their root. Designs will operate and deploy in novel ways, ensuring a bright new future for military wars that have no equal, faster, smarter, or more effective than all previously known tank designs. Through the ages, tank design has evolved significantly over the decades, driven by the ever-changing demands of modern warfare. During World War II, tanks were initially designed for relatively simple roles but quickly adapted to the increasingly complex battlefields of the time. Early war tanks, such as the British Matilda and the German Panzer, were often lighter with less armor and smaller guns. However, as the war progressed, the demands for greater firepower, protection, and mobility led to the development of more powerful and heavily armored machines. Tanks like the German Tiger and Soviet T-34 emerged, combining enhanced firepower with innovative design features such as sloped armor for better protection and wide tracks for improved mobility across rough terrain. As tank technology advanced, so did the strategies and tactics employed on the battlefield. The tanks of World War II demonstrated the importance of versatility, with many nations adapting their designs to meet specific needs. For example, the M4 Sherman, which became the workhorse of the Allied forces, was designed for mass production and mechanical reliability, making it highly effective despite not being the most powerful tank on the battlefield. In contrast, the German Tiger, renowned for its powerful 88mm gun and nearly impenetrable armor, became a symbol of German strength but was plagued by mechanical issues that limited its effectiveness in combat. The evolution of tank designs during this time reflected the critical balance between firepower, armor, and mobility, each aspect contributing to the tank's success in different operational contexts. It can even be said that tanks evolved continuously even after World War II had passed, continuing to intensify geopolitical tensions by superpowers of the world, as is also known from their bitter continuing mechanism of the arms race. Survivability capacity continued to emerge with their main orientation becoming offensive. For example, the M1 Abrams represented a revolutionary design during the 1980s, with composite armor and a powerful 120mm smoothbore gun. Its advanced armor, composed of layers of ceramic and reinforced steel, was one of the most formidable ever built, enduring enemy fire and continuing to function under extreme conditions. On the other hand, the Soviets churned out two models, the T-72 and T-80, both emphasizing firepower and reliability to ensure that the USSR had matched the technological innovation in the West. The light, easily maneuverable trend of tanks caught fire in the latter decades of the 20th century as militaries came to realize that movement speed was not only necessary but equal to the necessity of agility. This new generation can be represented with the South Korean K2 Black Panther and Japan's Type 10. These composite material tanks also reduce weight while not reducing the durability of these tanks. In this context, the K2 Black Panther tank weighs 55 tons and, with future advanced fire control systems, is good enough for modern high-speed warfare. Future tanks will opt for mobility and maneuverability in a dynamic and complex battlefield. This will move from the heavy and clumsy tanks of old to a much more sleek and efficient design suitable for modern and future battle conditions. The historic impact of tanks in warfare is undeniable. Tanks have long been associated with modern warfare, and their impact on the battlefield is undeniable. The introduction of tanks during World War I marked a groundbreaking shift in military strategy, but it was in World War II that their role became truly transformative. Tanks fundamentally altered the way wars were fought, providing unparalleled mobility, firepower, and protection. They allowed military forces to push through entrenched defensive lines and perform offensive and defensive operations with efficiency. Their arrival on the battlefield changed the entire dynamics of land warfare, making them indispensable to both the strategic and tactical elements of military campaigns. The strategic importance of tanks during World War II cannot be overstated. As armies faced new and more complex challenges, the tank emerged as a key player in many pivotal campaigns. The use of tanks in offensive operations, such as the blitzkrieg tactics employed by Germany, proved to be a revolutionary approach to warfare. The speed and mobility of tanks allowed for rapid breakthroughs, overwhelming enemy defenses with precision and force. On the defensive side, tanks were essential in holding strategic positions, using their heavy armor and firepower to resist enemy advances and secure vital areas, including during some of the most significant battles in history. In the European theater, tanks played a very important role in the D-Day landings, where armored vehicles were essential in securing beachheads and providing cover for advancing infantry. Indeed, the enormous numbers produced by the major powers during World War II, the United States, the Soviet Union, Germany, and Britain, are said to have secured a decided advantage for the Allies. It's interesting to note that one of the iconic and reliable tanks produced among other producers by the United States became the M4 Sherman. The Sherman was an easy model to build, mechanical and robust. Using the Sherman, the Allies made it into the war, whereas the Panzer and Tiger were very tough German tanks. Each country's tanks represented the product of its specific philosophy in design and military strategy. For World War II, the Soviet T-34, with sloped armor and wide tracks, was hailed for its mobility and effectiveness on the Eastern Front. German tanks, the Führer Tiger and Panther, featured firepower and armor that filled enemy forces with fear. However, their sophistication came at the expense of mechanical and manufacturing problems such designs entailed. At the end of the war, tanks had achieved a secure place at the heart of modern ground combat, creating a momentum that drove well beyond the immediate post-war years into the Cold War competition for high-tech battlefields and the doctrine-related technological design pressures it placed on armored forces in perpetuity. The role of tanks in modern warfare continues to be pivotal. Tanks act as the cornerstone of ground combat and strategic operations. In recent conflicts, such as the Russo-Ukrainian War, the importance of tanks has remained evident, even as their traditional strengths face new challenges. Modern tanks, such as the M1 Abrams and the T-72, continue to provide key advantages, including mobility, firepower, and protection, which are crucial for breaking through enemy lines, securing territory, and providing vital support for infantry. However, these heavily armored vehicles also face new threats on the battlefield, including advanced anti-tank missiles, drones, and other modern weaponry that pose significant risks to their dominance in land combat. Despite their undeniable power, the role of tanks in modern warfare is becoming increasingly complex. Their substantial weight and fuel consumption present significant logistical challenges, particularly in long-term operations where rapid mobility and resupply are critical. Tanks like the M1 Abrams, which weigh around 67.6 to 73.6 short tons, are highly effective on the battlefield but struggle with maneuverability across soft terrain such as mud or snow. This weight also limits their ability to be easily transported, as moving such massive machines requires specialized equipment and careful logistical planning. In modern military operations, tanks are often deployed far from home, and the complexity of transporting and maintaining them in remote conflict zones remains a significant hurdle for military forces. The ongoing Russo-Ukrainian war has unveiled the weaknesses of conventional tanks in modern conflicts. Although modern tanks are well equipped with advanced armor and armament, they are not invincible. More than 8,000 Russian tanks have been destroyed or put out of commission, revealing that despite the level of technological progress, tanks remain vulnerable to many types of modern anti-tank weapons. The future designs of tanks should be robust, versatile, and capable in order to handle the new threats of drones and precision-guided missiles. Such lessons learned during these conflicts have pushed military strategists and engineers to rethink how to design the tank in a new light, where protection systems would be more effective and maneuvering greater in nature. To remain relevant in modern warfare, the next generation of tanks will be designed with more focus on speed, agility, and flexibility. Future tank technology will integrate lightweight materials, hybrid electric engines, and advanced AI systems that improve performance on the battlefield while addressing some of the traditional weaknesses. Hybrid electric propulsion will ensure a reduction in fuel consumption and a higher operational range for tanks, thus becoming critical in protracted conflicts. Such systems are also expected to completely change the way a tank operates, thereby making it more autonomous and efficient, with a reduced burden on the personnel operating it and making it smarter in its response to battlefield conditions. These innovations, coupled with greater mobility and more efficient logistics, will ensure that tanks remain an important factor in modern warfare while changing to fit the evolving nature of combat. But even with all their power, tanks still have some major weaknesses on the battlefield. What if their size and fuel consumption are holding them back from being as effective as they could be? Traditional tanks, despite their overwhelming firepower and protection, come with significant limitations that hinder their effectiveness in modern warfare. One of the primary drawbacks is their immense weight. Tanks like the M1 Abrams, weighing approximately 70 tons, are formidable on the battlefield but struggle with mobility, especially on soft terrain such as mud, snow, or marshlands. This weight limits their ability to quickly maneuver across different types of terrain, which is crucial in rapidly changing combat environments. The mass of these vehicles also creates logistical challenges, as they require specialized transport equipment such as massive cargo planes or transport vehicles, which can only move a limited number at a time. Another limitation of traditional tanks is their high fuel consumption. For instance, the M1 Abrams, with its gas turbine engine, consumes about 1 gallon of fuel per 0.6 mile, making it highly fuel inefficient. This excessive fuel demand presents a major logistical headache for military planners, particularly in conflicts where resupply lines may be interrupted or difficult to maintain. In long-term operations, this problem becomes even more pronounced, as constant fuel supply is necessary to keep tanks operational. The need to transport vast quantities of fuel to support tank movements across battlefields, especially in remote or resource-poor areas, makes their sustained deployment a complex and resource-draining task. More than that, old-style tanks with advanced armor and weaponry are always open to advanced anti-tank arms and war tactics. The Russo-Ukrainian modern war has demonstrated in the global world how even modern armored tanks, such as the M1 Abrams or T-72, can also be brought to a halt through anti-tank missiles, drones, and other technology. Over 8,000 Russian tanks have been destroyed or disabled in the conflict, and it's an important point that even the most powerful or well-protected tanks are not invincible. As precision-guided missiles and autonomous weapon systems continue to proliferate across the battlefield, traditional tank designs are increasingly vulnerable to these emerging threats, making constant adaptation in design and deployment strategies inevitable. Lastly, The sheer scale and complexity of conventional tanks lead to enormous maintenance and operational difficulties. Heavy tanks require large crews, specialized repair teams, and frequent maintenance that can be costly in terms of military resources over long periods of conflict. Also, the logistics of moving such monsters around different theaters of operation is a heavy burden. For example, transporting a 70-ton tank long distances in the air is such an endeavor, requiring so much coordination and resources. All these have driven the military to reconsider how tanks have traditionally been designed and think outside the box about the solutions available for overcoming their inadequacies in terms of continuing with armored combat machines. Advancements in tank protection and stealth technology have become essential as modern warfare introduces new threats that traditional armored vehicles may struggle to defend against. Tanks, once impervious to most battlefield threats, now face sophisticated anti-tank missiles, drones, and precision-guided rockets that can pierce even the heaviest armor. To counter these emerging threats, modern tanks are equipped with cutting-edge active protection systems, APS, like Israel's Trophy system, which detects incoming projectiles and neutralizes them before they can strike. This system deploys a combination of jamming signals, smoke grenades, and even counter-projectiles to intercept and destroy anti-tank missiles, providing a crucial defense against modern weaponry. Alongside active protection systems, stealth technology has become a crucial component in enhancing the survivability of tanks. As the battlefield evolves, tanks need to become harder to detect, not only by the human eye but also by electronic surveillance and targeting systems. New stealth technologies are designed to reduce a tank's heat, noise, and electromagnetic signatures, making it significantly more difficult for enemy forces to pinpoint its location. By blending into the surrounding environment or masking their presence, tanks can avoid detection and gain the element of surprise. These stealth capabilities are particularly valuable in situations where tanks must operate close to enemy lines or in highly contested areas. More than this, advanced camouflage systems are being developed to make tanks even more elusive. Israel has been working on adaptive camouflage technology that changes the appearance of the tank to match its surroundings in real time. This adaptation gives tanks the ability to blend into diverse environments, whether urban landscapes or forested terrain, and hence are harder to target. As detection technologies advance with the advent of drone and satellite surveillance, the need for such adaptive systems will only increase. With these more advanced camouflage techniques, tanks can operate with increased freedom while minimizing their chances of being targeted by the enemy. The future of tank protection will also be in lighter, advanced materials that will enhance defense without compromising mobility. Innovations in armor technology, such as synthetic resins, ceramics, and composite materials, are helping create lighter yet stronger armor plates that give superior protection against incoming fire but reduce the weight of the tank. The same would give even greater flexibility with easier transportation, answering some of the age-old criticisms heavy armor had faced. An integration of advanced armor, active protection systems, and stealth technology would keep future tanks geared for increasing weapon sophistication, where it can prove that tanks once again have the power on the ground. The integration of artificial intelligence, AI, and automation into tanks represents a monumental shift in how these vehicles will operate on the battlefield. Traditionally, tank crews have been responsible for everything from navigation and target acquisition to maintenance and operations. With the advent of AI, many of these tasks are increasingly being handled by intelligent systems, allowing crews to focus on more strategic and mission-critical decisions. AI-driven systems can enhance tank performance by providing real-time data analysis, optimizing route planning, and improving targeting accuracy. As AI becomes more integrated, future tanks could operate with greater autonomy, increasing their efficiency and effectiveness in combat situations. AI's ability to assist with routine operations is another game-changer for tank crews. Routine tasks, such as diagnostics, maintenance scheduling, and even battlefield management, can be handled by onboard AI systems, reducing the workload on human operators. This not only enhances operational efficiency but also ensures that tanks remain in peak condition without the need for constant human oversight. By offloading these responsibilities to AI, the human crew can dedicate more time to responding to battlefield dynamics and making quicker, more informed decisions. This shift toward automation allows tanks to operate with fewer crew members, a crucial consideration as the trend moves towards smaller, more agile armored vehicles. One of the major advancements with AI integration is that a future tank may optionally be manned or fully autonomous. For instance, the U.S. Army has been working on the Optionally Manned Fighting Vehicle (OMFV) program to replace the Bradley Infantry Fighting Vehicle. The OMFV will be designed on an open architecture, which will make it easily upgradable in terms of technology and can function with minimal human interaction. This vehicle will depend upon AI system capabilities in many tasks that would otherwise be carried out by human crews and hence offer better protection with more firepower. The unmanned and optionally manned vehicles are among the several key steps toward reducing human risk in combat, yet still offering a highly lethal and efficient asset on the battlefield. In this regard, AI and automation also make tanks more intelligent in how they interact with other military units. With AI systems, it will be easy to communicate and coordinate tanks not only with other armored units but also with infantry, air support, and artillery, thus bringing more connection between the different players on the battlefield, leading to better synchronization for more precise attacks. This way, AI would help tanks change with the dynamics of war as it senses data in real time and adapts its strategy according to it. As the development of AI progresses, it is going to increasingly be the focal point for turning tanks from simple, heavy machinery into highly sophisticated autonomous platforms capable of executing complex tasks on the battlefield with much speed and accuracy. New trends in tank armor and firepower are also shaping the future of armored combat. The evolution of tank armament and firepower has been pivotal in maintaining the relevance of armored vehicles in modern warfare. Historically, tanks were equipped with 75mm and 88mm guns, which evolved into the powerful 120mm smoothbore cannons seen in many contemporary models like the M1 Abrams and T-80. However, as the need for greater firepower grows, tank armament is shifting toward even larger calibers. One notable development is the Main Ground Combat System (MGCS), a joint project between France and Germany, which plans to equip future tanks with a 140mm cannon. This upgrade would significantly enhance the ability of tanks to engage targets at longer ranges, offering more devastating firepower and greater precision while shifting the balance of power on the battlefield. The transition to larger caliber guns, however, is not solely about increasing the physical size of the cannon. Tank firepower is also being redefined by the integration of advanced ammunition types and the implementation of autoloaders. The move toward 140mm guns reflects an industry-wide trend to improve the lethality of tank weapons by making them capable of destroying enemy vehicles, fortifications, and even aircraft with greater efficiency. Autoloaders, which automate the process of loading shells into the tank cannon, are also playing a significant role in this shift. By eliminating the need for a human loader, autoloaders improve the speed and reliability of firing, a key factor in tank effectiveness during fast-paced combat scenarios. One advantage of autoloaders is that they simplify tank operations, and crews are then available for more task-oriented and critical activities rather than a role that is mostly manual loading. With the decreasing size and increasing compactness of modern tanks, a smaller crew increases the importance of efficiency in all aspects of operation. Autoloaders ensure that tanks can maintain high rates of fire without requiring additional manpower. Although some people think that autoloaders can be less reliable than human loaders, the benefits associated with speed, accuracy, and reduced manpower are significant, considering the general trend in tank design for lighter and more agile vehicles. Beyond the issue of the weapons themselves, the evolution in tank armament also responds to the increasing relevance of electronic warfare and targeting systems. Modern tanks have fire control systems that significantly enhance their ability to target more precisely, even from a moving position. These systems incorporate data from several sensors, such as radar and infrared tracking, so the tank can accurately strike its target from long distances. The integration of AI and automation also plays a key role in the improvement of accuracy in the firepower of tanks because these systems can rapidly analyze battlefield data and make real-time adjustments to ensure the highest level of effectiveness. Future designs will depend on a combination of advanced weaponry, intelligent targeting systems, and automated processes to maintain a decisive advantage in combat as tank firepower continues to evolve. But it's not just about firepower anymore. The way tanks are built and deployed is about to undergo a massive transformation. The future of tank design and deployment is being driven by the need for greater agility and adaptability in modern combat. As military forces around the world face new and more unpredictable challenges, tanks must be reimagined to operate with unmatched speed and precision. One of the key advancements in future tank design is the shift toward modular platforms, allowing for quick upgrades and easy adjustments depending on the mission. These modular tanks could be customized for specific environments or combat situations, providing military forces with greater flexibility. The ability to swap out or upgrade certain components, such as armor, weapons, or communication systems, will ensure that tanks remain relevant as technology and battlefield needs evolve. In addition to modularity, autonomous capabilities are also expected to become a feature of next-generation tanks. While the fully autonomous tank is still years away, improvements in AI and robotic systems will allow tanks to operate with a minimum of human intervention. AI can help identify targets, make decisions, and even navigate, thus reducing the cognitive load on tank crews. This would also open up the possibility of unmanned ground vehicles, where tanks can carry out missions without having direct human oversight. As the technology of AI advances, so will the possibility of tanks working in autonomous operations on the battlefield, significantly improving their effectiveness while minimizing the loss of human lives. Future tank designs will also emphasize rapid deployment. The ability to move tanks quickly from one location to another is very important in modern warfare, where the element of surprise and the ability to adapt to changing situations are what can make all the difference. Transportability will become a key design consideration, with tanks built lighter and more compact. Thanks for watching. If you enjoyed this video, don't forget to like, comment, and subscribe for more exciting content. We'd love to hear your thoughts, so drop a comment below and make sure to watch the next video on the screen for more fascinating insights. See you in the next one.